So you would have watched the video for this slide deck already on the periodic table and some brief introduction to periodic trends. Having watched that, you should now be able to fill in some blanks from this note over here. So let's go through that together. Let's see how much you can remember. So the whole focus of the lesson is the periodic table, how it's organized, in the periodic law. So the periodic law is when you have the chemical and physical properties of elements repeat in a regular periodic pattern when they are arranged according to their atomic number. So when you put them according to their atomic number, there's going to be patterns that repeat themselves in terms of chemical properties and physical properties. Remember that one thing to really emphasize here is valence electrons. They're super important. And so one pattern that you may have noticed is the valence electrons are the same in all groups. And the reason we care about valence electrons so much is really because they're the ones that are responsible for forming chemical bonds between atoms. And when we study reactions, that's what we're going to care about the most. So let's go take a look at how the periodic table of elements is arranged and take a look at some basic trends. So remember that if you look at the periodic table, you have groups, which are the vertical columns kind of going up and down like this, and there's 18 of them. And the groups or families, the group number will determine the number of, that's right, valence electrons. Valence electrons. And elements in the same family will have similar chemical and physical properties. So for example, all the elements in group 1, other than hydrogen, which is a nonmetal, are alkali metals, and they're all very reactive with water and air because they only have one valence electron. Another aspect of the periodic table is the periods, or the periods. Those are the horizontal rows, so basically going from left to right. And so what they will tell you are basically the amount of energy levels or shells that an atom has. So in the first period, 1 shell, second period, 2 shells, so on and so forth. And there's also trends within the periods as well. So you might see reactivity trends. For example, you might get more reactive for a nonmetal when you go from left to right in a period, or more reactive for a metal when you go from right to left. And we'll see more of that later on, but the point of what you get is that there's also trends involved there as well. So a few trends you might see is that the atomic number increases from left to right in a period. So for example, if we go to our periodic table over here, atomic number is 1, and then from left to right 2, so that went up. And over here, atomic number is 3, 4, it goes up from left to right. Just to highlight, this is a period, this is a period, this is a period, that's a period, and there's 7 periods, don't forget. These two do not count as separate periods. The lanthanides are part of period 6 over here, and the actinides over here are part of period 7 over here. So there's only really 7 periods. So just keep that in mind as you study the periodic table. So let's go back to our notes that we're going to fill in. That was our first trend. And then another way the periodic table is organized is based on the location of the classes of elements. Remember that metals, they're found on the left side of the table, and nonmetals are found to the right side of the table. And I really should say metals are to the left of metalloids, and nonmetals are to the right of nonmetals, metalloids. So let's go take a look over here. All members of a period have the same number of electron shells, or you can call them orbits as well, right? That's just a different word for it. And then I'm just repeating this here again. You should be able to fill it out by now, but all members of a chemical family have the same number of valence electrons. So that we already went over, and you were most likely able to fill in those blanks. So you can see over here, group 1, they all have 1 valence electron. Group 2, they all have 2 valence electrons. Group 13, they all have 3 valence electrons. And then it continues that way. In period 1, they all have 1 shell. In period 2, they all have 2 shells. Another pattern you might notice, if you go down a group, notice what's happening to the size or radius of the atom. It looks like it's getting larger. Hydrogen, lithium, sodium, potassium. Potassium is larger there. Beryllium, magnesium, calcium, larger there as well. The pattern going across is not quite accurately drawn here, so don't worry about that. But just going down, you'll notice there's a pattern there because there's more shells. But we'll discuss that in more detail later on. But there's a lot more trends than just the valence electrons and the number of shells. Then we also saw in the presentation in the slide deck that there's 3 classes of elements. And so you can go and fill in these blanks based on the properties that you know. Something that's lustrous, something that's found on the left side of metalloids. So we know those would be our metals. And then anything that seems to be the opposite of that description, so something that's dull, something that's not Chinese dull, that's not malleable, that's not ductile, that are poor conductors, those would be the non-metals. And then there's one more class left, which is basically along the staircase and somewhere in between both metals and non-metals, and we call those the metalloids. And then finally, we can divide the metals and non-metals up into separate groups or families. So, for example, the metals can be alkali metals or alkaline earth metals, and the non-metals can be halogens or noble gases, and there's other divisions there too, but these are the main ones we discuss. So lithium, sodium, and potassium are examples of these types of metals, and that would be alkali metals, or the group 1 metals, very reactive with water because they only have 1 valence electron. Our next one, we have beryllium, magnesium, and calcium. Those are examples of these metals here in group 2, and those are alkaline earth metals. So alkaline earth metals. They have 2 valence electrons. They're reactive, but not as reactive as the alkali metals. Alkali metals are also quite soft. You can cut them with a knife, but alkaline earth metals, they're harder, so you couldn't. And the other thing with alkaline earth metals is that they typically burn in a bright fire. And they burn bright colors in a fire. Our nonmetals can be divided into halogens and noble gases. So things like fluorine, chlorine, and bromine, they're in group 17. Those are the halogens. They're quite reactive for nonmetals because they have 7 valence electrons and they want to gain 1 more electron to have a full shell, so they're very, very reactive as a result of that. Some examples are fluorine, chlorine, and bromine. Hydrogen doesn't count as one of these. It's just this periodic table put it here just to show it's actually a non-metal, but in reality, hydrogen's in group 1. So fluorine, chlorine, and bromine are all very reactive. They're all halogens. Same thing with iodine as well. Then we have our last group over here. Things like neon, helium, argon, krypton. They're all very, very stable, not very reactive because they have a full valence shell. And these ones here in group 18 are called the noble gases. So they have their stable octet or their noble gas configuration, which makes them very stable. So just a reminder, these are group 1 for alkali metals, group 2 for alkaline earth metals, group 17 for halogens, and then group 18 for noble gases. And they have a full valence shell. We often call that also a noble gas configuration. They don't really need any more electrons, so they won't really lose or gain electrons. So they'll rarely form ions because ions form when you have when you have loss or gain of electrons. So they rarely form ions as a result of that. And one more thing to mention, here I say that fluorine, chlorine, and bromine are all reactive gases. And that could be true if it's not room temperature, but typically at room temperature, bromine's a liquid. And you would remember that by going to look at your periodic table over here and seeing bromine being blue at room temperature. But as a gas, it is still reactive, so that is still truth regardless. So that was filling in some blanks for the periodic table lesson. We got a brief overview and brief structural idea of how it's organized. And we're going to get to see more trends in the periodic table other than just number of valence electrons and number of shells based on periods and groups. that'll be coming up later on this unit.